Hi, welcome to 405 Videos. This is DC here. In this video, I'm going to show you how to use ICODE SLIX tag using PN5180. So you're going to learn everything about ICODE SLIX tag, and at the end of the video, you will have a complete knowledge on how to use this tag and also how to program. So I'd like to go through this series of slides. After this, I'm going to show you working with the real tag. These are some of the high-level features of SLIX ICODE SLIX tag. This is compatible with the earlier version, that ICODE SLI. So this tag can be used as a SLI tag, and all the SLI commands, they do work. And if you have been following my series of videos, I mentioned that the SLI tag is the very first generation of the ICODE series from NXP. Looks like this is the next generation of the ICODE tag. So this tag has got exactly the same memory structure as SLI tag. It has got 32 blocks, and we know each block has got 4 bytes. The main difference is this card, the SLIX card, supports password, which is something every software system expect. So we don't want to have a very open tag. So the password protection here is not very comprehensive. It is just, I would say, just introduction of the password feature into the ICODE series. The password is a 32-bit password. It controls only the EAS and the AFI. We have seen in my previous videos how to use the EAS and AFI features. And in the documentation, this password is also called as EAS and AFI password. And the default password, that is the password of a brand new tag, is all bits set to zeros. So in order to identify the type of the tag type is used in the the 8 bits of UID. The tag type is 1. In fact, the tag type for SLI is also 1. The difference between the SLI and SLIX is, so you have to find out whether the bit 37 is set to 1, indicate this is a SLIX. It also means it has it supports a password protected EAS and AFI. Now all these things I'm going to show you when I start playing with the real tag. So this tag supports the option 1 in the following commands. Remember, when I demonstrated using the Texas tagit card, in the tagit, the write operation works only when the option flag is set to 1. We've also seen the option flag set to 1 in the SLI tag, but that does a different thing altogether. Probably SLI in SLI 1. By setting option 1, you get 5 bytes of data, the data plus the log byte. So here the option 1 is supported using the write block. Now you can still use a write block without the option set. It's actually, this is option flag. So I think it's best understood if I mention that as an option flag, because option flag is part of the request flags you send. And we have seen in early documentation that in the write operation with option flag set to 1, it becomes a 2-step operation. So you have to first send the command, then send a EOF signal. Only then the tag returns you the response of the write operations. Now this option flag is supported by the write single block, lock a block, write AFI, lock AFI, write DSFID, and log DSFID. In fact, you can still do all these operations without having the option flag set to 1. So depends on how you design your software. So these are the custom commands that are supported in this SLIX tag. It's all to do with the password. It has a command called get random number. This is used to send the password. So I'm going to explain about this from the documentation as well as right on the tag. set the password. This is like sending the password to the tag. Write the password. This is same as changing the password. Lock the password. Once the password is locked, it cannot be changed after that. And also, protecting EAS and AFI is an optional thing. Now, if you want to use this a SLIX tag, something like a SLI tag, then you don't have to worry about these custom custom commands at all. So you can protect just the EAS alone with the password, or just the AFI alone, or you can protect both EAS and AFI. So both can protect it. So this is completely optional. You're going to see these things in next few minutes. Now this is what this is what SLIX tag is all about. Now I'm not going to cover the things which is already been covered in SLI videos. Would advise you to see that videos. I'm going to cover something which is available only in SLIX. Probably at the end of this video you will be comfortable with these custom commands. Just to make this concept complete, I've also listed out some of the applications of this SLIX tag. This is taken from the documentation, the datasheet, and I've seen these type of tags used in the pharmaceutical supply chains. I've also seen these sort of tags used in the counterfeit protection of goods, and you can use this wherever you got an idea. So it's all how we use these tags. It all depends on your skills and your imagination. So this is just an NFC tag with the features. With every NFC tag has got different features. Now if you want to use this SLIX in your project, you just have to understand all the features this SLIX tag has and decide whether it is the best tag to do your software project. To better understand this tag, I would advise you to get this datasheet from internet. And this is a very simple to understand document. If you have been following my videos, so you'll understand every line of this bit, except those things where the signals or the voltage level speaks. Otherwise everything is easy to understand. So more or less everything is same as SLIX, SLI, except this one. Now as I mentioned this before, you can protect EAS and AFI with the password. Now without the password authentication, you cannot change the EAS. So when I say change the EAS, it means to enable the EAS or disable the EAS or lock, as well as to change the AFI or to lock the AFI. So to do all these operations with EAS and AFI, you can protect by password. Now likewise, you can go through all the every pages. They're all it's really easy to understand every line of this page, except these type of things which I myself don't know. The first thing a developer or a student would like to know is about all the commands supported by this tag. So I mentioned this in my earlier part of this video. This tag supports the write single block with option flag set to 1. Now again, this is an optional. You can still write to a block without thinking about this option flag set to 1. Likewise, the log block works with option flag set to 1, and read multiple blocks. The option flag in read multiple blocks is something different from the others. So look at the way this the password protect EAS and AFI is used. Here the option flag behaves as a parameter. Now the password protect, when you call this command or when you send this command with option flag set to 0, you are protecting just the EAS. If you pass this command A6 with the option flag set to 1, then you are protecting the AFI. So here the option flag behaves completely different. So if you want to protect both EAS and AFI, you have to send this command twice. The first time with option flag set to 0 to to enable password protection for EAS. After that, send the same command again with option flag set to 1 to enable password for AFI changes. Now that's really simple as that. So other thing you have to notice is how to determine whether the tag is a SLI or SLIX. Now here again is mentioned in this table. It says the bit 37 is set to 1 if it supports password. If it supports password, it is not SLI. It is SLIX, or now you're going to see in my next videos it could be the SLIX 2 as well. So let's play with the brand new SLIX tag. You can see the version of the software is 2.4, and if you look at the release notes, couple of things have gone into the software since my last video. It is probably the last video was on using the custom commands in the target. Now I've showed you how to write two blocks at a time, or log two blocks using the target tag. So also a new tag has been added here, a new type of tag, that's a Topaz 512. You can play with a Topaz 512 tag using this PN5180 board. There's some interesting concept that has gone into the programming 5180 in order to use a Topaz. So this probably now I'm going to do explain this future videos. There's so many interesting concepts you're going to learn along with the Topaz. So here, this is the one, a new feature has been added to work with the ICODE SLX tag. If you already got this software, you have to upload the Arduino hex code, and also because you get the source code of the Arduino, you will know how to program the ICODE SLX using Arduino and this board. So I'm going to connect, and if you see this thing, you got the Topaz here. So I'm going to use IS15693, place a brand new tag. Now as we did before, first RF1, activate. So the software has detected it's a ICODE SLIX tag, and if you go to system, get, now you can see this is exactly the same feature as SLI. Now I'm going to bring everything into the software, the entire data. So I'm going to use the option 1. So read all, this option 1 brings you on the log data. As you can see, this is a brand new tag. Now I'm not going to explain anything about all this stuff. We are going to focus on this tab, ICODE SLIX. The top two section up to here was present in the ICODE SLI tag, and I've also explained how this thing works. We have seen how to enable, how to reset or disable and see the alarm and lock EAS. These are the new things in SLX. So you just have to understand how to work with this part of the software. That's it. So with this knowledge, you can put a tick on your list of things. Okay, so I'm going to focus on this first. It's everything to do with the password and protection. That's all. Now first, if you think this screen looks very complex, please follow my video. Do exactly the way I show in this video. So once you understand the basic concept, and it's all up to you, you can play with that and do whatever you like. So I'm going to modify the AFI, because AFI is modifiable in the brand new tag. I'm going to change this as to 1. Set. Now you got a nice message here, and we still don't know whether, I know it's 100% working, but if you want to check, just make it as 00 and click on get thing up. Okay, I know why the get is not work. You have to remove this option flag. Get, yeah, you can see that the AFI has been written successfully. Now, because this is a learning tool, so you have to be very careful when you set this flag and do some operation and go back and try to do something else. Now, what went wrong, just a few seconds ago was the get operation does not work when the option flag is set to 1. However, we had this option flag set to 1 at the beginning of this screen. If you want, we wanted to bring all the data along with the lock. So that's the reason why option flag was set to 1. So here it's fine. And same thing, I can, if you click on alarm is set. I might have said this before. I can go and disable, reset the alarm. Alarm reset is working. If you say alarm, you get an error message. You can set the alarm. Okay, I can enable this. I can enable the EAS, and if I go and hit alarm, it works. So here it's pretty open. Unless this is locked, unless it is locked here as well. So anytime you can go and enable and disable here, or keep on changing AFI. So we are going to stop that. We are going to protect those operations by means of a password. So in order to do that, you have to first send the password. Okay, if you see the documentation here, now this is very interesting to read. Here, what it says here is, the first thing you have to do is protect. Assume that you decided to protect EAS and AFI the password. The first thing you do is you have to first send a valid password. Now I know that for a brand new tag, the valid password is the 0. You have to first send the password. Okay. Now sending the password is again a two-step process. First you ask the tag to give you a random number. Then you XOR the random number. So you have to look into this set password command structure in the documentation. So before sending any password, you have to first get the random number. You can use this. It's a nice utility to have. Whenever you want a random number, you can use this tag like this. So by sending this command, this is the custom command. Obviously, all custom commands will have the manufacturer code. You can send the custom command with the address mode or non-address mode. So there is something mentioned here about the address and non-address mode. So here I'm not going to use an address mode. So this returns a 16-bit number. So the first step is get the random number from the tag. You get 16-bit number. Use that to XOR. Use that to manipulate the password. This is the reason could be just kind of a to make sure that the data is valid, and all sort of security features, probably a kind of a simple security feature. If you look at the set password command, it says you have to see set password is a 32-bit password. We know that. Now you have to use the random number. Say random number is 16-bit number. You have to XOR the top 15 bits, the top 16 bits with the random number, plus you have to XOR the lower 16 bits with the random number. So you have to XOR this our password with this random number. So that's all document it says here. Now after XORing, you're going to send the XORed password with this custom command. So again, the command structure is pretty straightforward. Just go through this once, so at least we'll cover this command structure. You got a flag, you got a set password command, that's the bytecode for that. You got the manufacturer code. You got, if you're sending the address mode, it is in this will have 8-byte number, and you're going to send the password identifier. Now there's only one password. This is again, there's something you can see what the future tag is going to be. So because this has got only one password, that's EAS or AFI password, this is always fixed to 10, and your 32-bit XOR password. So that's all. You just have to pack all these bytes together, send it. So I'm going to, this look a bit complex initially, but it's pretty easy. So follow my videos, follow the steps. First thing, okay, get the hit this get command. So you can see there is a get random number command is sent. You can keep getting random numbers as many number you like. Okay, I can also use the address mode. If you tick here and get the random number again, the only thing you say is you'll have the UID of the tag in this command. So you know how the get random works now. So I'm going to take out this address mode. Next is you have to first validate with the correct password. I know that for brand new tag the password is zeros. You can see here this is XORed with this, so you just have to go to your like a basics of bit operations, the XOR operation. Okay, the way it works is your 32-bit password, which is okay, sorry, the screen is pretty slow here. Now you have to XOR. Now if you XOR this with the number here, if you can see here, because my password is all zeros, when you XOR you end up getting the same random numbers twice here. Now then hit this set. Okay, now the set command is something different actually, so probably to see the documentation. Okay, so there's something very important information you have to notice here. Okay, this bit. Now this is present in many commands in this tag. So if you come across this, it says the set command can only be executed in addressed or a select mode. Now we have covered a little bit of a select mode in earlier videos. However, I'm going to have a separate video on understanding select mode. But at this point of time, I'm going to use the address mode. Okay, the software is already showing you, already shows a warning here. So as soon as it says please select the flag either select or address mode. I'm going to use this address mode for the time being. Then I'm going to say set. Yeah, okay, so I have set. Now the tag knows that this software is authenticated now. Now after that you can lock. So just to understand that locking can be done separately for this and this, I'm going to protect just the EAS. Before that, let me try what's the status of this alarm. The alarm is set, and I'm going to reset this thing before I do that. Yeah, now I know that my EAS is not enabled. Okay, so now I'm going to protect my EAS. Protect EAS. It says, oh, this is a wrong message. Yeah, password protected. This could be copy paste. This could be, I think it's a password protected EAS. Now EAS is protected by a password, so you cannot enable or disable EAS or lock EAS without first authenticating. I'm going to take this tag out. Now come back to this tag again. Now we're going to, I don't need to do RF on because it's already on. Activate, go to system here, and if I try to, I know this is EAS disabled. Try to set this EAS. Now we got an error. Now it's because setting or disabling, enabling EAS is now password protected. So if you see the command structure, there's no response from the tag. You'll come across these type of things. The tag does not return any error message, it just ignores it. Now when you start programming, you have to keep this in mind. You might end up getting nothing, and you should consider that as an error. So the only option what you got is I have to first send my password. The same thing, whenever you send password to the tag, first get the random number and enter your password. Say whatever is the password, this could be a password. As soon as you type here, the software XORs and shows you the XORed value. Now my password is 0, and I'm going to set it. Again, set password, address mode, set password. No, password is set. So with this state, I can now enable and disable this EAS. We wanted to enable the EAS, so set enable. Look at that, you are now able to set this EAS. I can disable it, I can enable it, I can lock as well. We're going to do this at the end of the video. So alarm, reset, alarm, error, set, alarm, yes, okay. So this is how about going back to this AFI? Can I change this thing to 3.1? Now I'm going to take this, yeah, we'll keep this address mode. So set AFI is alright. If you want to make sure it's written, go and take out this address flag and go to system and say get. You can see that your so we are able to probably did something. Probably what you can do is you can close this thing for a while, come back here, activate, get thing. I'm going to change that, that we are still not authenticated with the password, so we're going to check, make sure that AFI is not protected by the password. Set. Now AFI is set. If you go and get, we're able to get. Okay. If you try to do the same thing for, you can always read the alarm, that's fine, but you can't change the state of the EAS. Can you set it? You got an error because it's now password protected. Okay. So next I'm going to do exactly the same step. This time we're going to protect the AFI. Now I've already reactivated the tag. So first thing is you're going to get a new random number. Hit this get, you got a random number, and the password is still the same, it's 00. I'm going to set. Before setting, you have to make sure it's in address mode. Set the password, it's fine. I'm going to lock AFI. Now, yeah, look at that. The software knows that if you want to lock AFI, you have to have this option flag set to 1. Now we are in a situation, it's a very interesting situation here. So we have got address flag and option flag set to 1 as well. So forget about the address flag. Sorry, I think you need address flag, sorry. Now let me check. If you see this, now one more important thing you have to notice here. Now the documentation says once the EAS and AFI is password protected, you cannot disable it. It's just like a one-way. You cannot unprotect it. It's very obvious because there's no command to unprotect the password. And also there's no mention about whether this command needs sending with the select flag set to 1 or address mode. So we are okay with not having this address mode. The only thing you have to keep in mind is if you want to protect AFI with the password, you must have the option flag set to 1 and hit this AFI. Now we have protected this AFI. So now we have got AFI password protected. You cannot set or lock it. Now let's try to do that. I'm going to close this screen, come back again, activate, get the system, try to change with the next one, set. You cannot change because now it's password protected. Now go back, get a new random number. Our password is still the same. Set it. Oh, I always forget this. Set with the address mode. Set this. Now we are able to change the AFI, sorry. Set. Now we're able to set. You can lock as well. So again, keep in mind there's no way you can undo the lock. So next I would like to show you how to change the password. It's called the write password. So if you're doing this from the beginning, probably before you change the password, you have to first authenticate with the old password. So get, now here I'm going to, I would assume that I want to change the password. I want to change the password to something other than the default one. So first you have to authenticate with the old password. Get is a random number and this is fine. Go to the address mode and hit the set. Now your password is sent. I want to change the password to 1. I don't want to make it complicated. Instead of 0, set to 1 and say write password, okay. So looks like the write password also requires address mode or a select mode. Again, the documentation says whether what should be the the prerequisite. Okay, so here write password is okay. Now my password is no more 0, so it's set to 1 now. Now if I come back again, it doesn't require actually. So go here, get. So if I want to change, alarm is fine. If I want to change the AFI to say next number 61, set I can't. So first I have to authenticate. I'm going to authenticate with 1, and before that, sorry, you need to get a random number. This is my password. This is before you do, set the address mode to 1. Now set it. Now password is set. Go back and try to change to, not sure, 671. Oh, sorry. Set. We are able to set the password. Set the AFI. Now what happens when I authenticate with the wrong password? Now the datasheet says if the password is wrong, the tag will not respond to any further commands. You have to reset or take the tag out of the RF field. Let's give it a try. So I'm going to authenticate with 0, which is the wrong password. Set the password, which is wrong. Oh, sorry. Addressed here. Set. Now the set password is error. Try to read the tag. Now looks like nothing has happened here. Yeah, so nothing is happening. Look at that. It says all these commands failed. So in fact the software was hanging a little bit. Now, all these commands failed. Now the only way to come out of this is take out the tag. In fact, you can try this magic here. Set this RF off. Now this should literally power off the tag. Set it to on again. Hope this works. And activate is activated. Okay, we are back in business again. Okay, so you don't have to take out this tag. The good thing of having this RF on, RF off on the screen, so you don't have to remove the tag. Just turn this, set this RF off. Everything works fine. So with that, if I want to, you can, even if you want to lock this thing. So assume that I want to lock my EAS. So to lock, this will fail because it's a password protected now. So what I'm going to do is validate with my password 1. Set. Now I'm going to lock forever. The alarm, can you try to reset it? You got error because once the EAS is locked, you can never unlock it. Same thing will also happen for the AFI as well. Anyway, I'm going to bin this tag now. I can lock this thing. Locked. That's it. Can you make any further changes here? Set. Now it's an error. So once it's locked, you cannot change. So what you have seen is it's the SLIX tag has got a password protection for just the AFI and EAS, and we also seen how the password is used. You have to first get the random number, and then you have to put in your password and get the XOR value, get the set. And you can also, I could have also locked my password. Let's give it a try. This is the last command you can do. So assume that I don't want to change my password anymore. Now I can lock it. So lock password forever. Yes, I'll lock the password. Now let's go to reset, activate, go here, authenticate with get a new password, authenticate successful. Let's try to change this to 2. Right, see the right field. So we are not able to change the password because it's locked. So it looks like we have seen, we have covered everything about this SLIX tag in this video. Now, only thing what is missing in this SLIX tag is there is no concept of auto locking feature. Say for example, the password is 32-bit. It's still possible, I don't know how long it takes. It could take years and years and years. Okay, so you might think, so is it possible to loop from 0 to say 2 to the power of 32 minus 1 and try to recover the password? In theory it's possible, but Just see the feasibility of these type of things. Okay, so that is not available in this SLIX. So I mentioned before, when you decide whether to use SLIX or whether you want to use a MiFi Ultralight EV1, see, Ultralight EV1 has a feature where the tag locks after sending in a limited number of wrong password, whereas if you're going to use SLIX for the same application, this doesn't have any auto locking or destroying the tag itself. There are features like this are available in the next generation of the, for example, SLIX2, or if you read about SLI-S, actually it's a different kind of tag. Now these two tags have got a feature where you can destroy the tag. So I hope you enjoyed this video, and looking forward to see you in my next videos. Thanks for watching.